Alright, rational numbers. Rational numbers are fractional. Just think rational is fractional. Hey, it rhymes. And any number that can be written as a ratio of two integers. And we only have one exception to that. Remember, integers are all the whole numbers and their opposites, but we do have one exception. Just like I before E except after C. The exception is you can't divide by 0. So 0 is an integer, it just can't be on the bottom. It can be on the top, it just can't be on the bottom. And why is that, you may ask? And let's go over a couple examples why that is. If we did 1 divided by 1, I think we could all agree that that's 1. If we did 1 divided by 0.1, how many tenths will go into one whole? 10. What if we did 1 divided by 0.01? We would get 100 of those will go into 1. And I think you can see that that gets bigger and bigger as that bottom number gets smaller and smaller. So the pattern's going to be, it's really going to approach infinity as this gets closer and closer to 0. So we'll say the value approaches infinity. So it's not real. Infinity is not a real number. So when fractions and integers collide, it can get messy if we don't know our integer rules. So our integer rules we got to remember. So using our integer rules for multiplying and dividing, an odd number of negatives gives us a negative number, and an even number of negatives is a positive. So all we do is count the negatives. So here's the deal. Positive fractions. Positive fractions can be a negative over a negative, or a positive over a positive. Because a negative divided by a negative is a positive, and a positive divided by a positive is a positive. And then negative fractions, using our integer rules, they can be written one of three ways. And negative fractions can be, we could say, a negative over a positive, or a positive over a negative, or, and this is the different way, a negative and then a positive over a positive. And that's really read like the opposite of a positive over a positive is how you can read that. That's because you have an odd number of negatives here. There's just one. And then that's just the opposite of a positive answer, which is negative. So an example for that one, let's say an example for positive would be negative 2 over negative 5, because that equals 2 over 5. Negative 2 divided by negative 5, that's an even number of negatives, so it's a positive number. And then an example for negative, remember we can write that 3 different ways. So that could be negative 1 divided by 4, or 1 divided by negative 4, or the opposite of 1/4. Now there's a proper way and there's an improper way. Just like a kid who has to go to the bathroom could say it one of two ways. The improper way would be, "Teacher, teacher, I gotta pee." Johnny didn't get the picture, did he? But Susie over here did. Susie says, "May I go to the bathroom?" So there's a proper way and an improper way. Same thing with writing fractions. Thank you, Susie, for doing that the right way. So Johnny over here showed us the improper way. Well, the improper way to do a positive answer would be a -2 over a -5. It's not simplified. The proper way, thank you, Susie, would be 2/5 without the negatives. And now the proper way to do a negative fraction could be, or the improper way rather, the improper way is when you put the negative on the bottom. So for instance, 1 over -4, that's just like, "Teacher, teacher, I gotta pee." But if you would put it on the top as -1 over 4, that's the proper way. Or you could also write it negative and then 1/4. That means the opposite of 1/4. Either way is proper for writing a negative fraction. These are the ways you don't want to write the positive fraction and the negative fraction. All right, I was glad I had some help for that demonstration. Right, now that we know how to write negative fractions and positive fractions, we can discuss equivalent fractions. So for equivalent fractions, when we rewrite a negative fraction, we want to make sure that it remains negative. And I can tell you this is where students make mistakes. We'll forget about that negative sign. And here's what I mean by that. If you had -8 over 10, and you wanted an equivalent fraction to -8 over 10, you could divide them both by the common factor of 2, and you would get -4 over 5. Now, a lot of times I see kids just write that as 4/5. They forget about that negative. So if the fraction's negative, don't forget to put that negative sign there. We can also write -8/10 if we multiply by the same number. Like if we multiplied by 3 to both sides, we would get -24 over 30. So again, don't forget about that negative. If the fraction was negative before you reduced it, it's going to be negative after you either reduce it or write an equivalent fraction. All right, now when we're graphing rational numbers, we still want to use integers on our number line. Now when we graph rational numbers, we still label the number line using integers like I said, but we can make hash marks for the halves or for the quarters or etc., whatever the denominator is out of. So for instance, if we were to graph -7/10, we can make our number line. 0 can go here, 1, -1. So we always use integers when we put those marks, those labels. And then -7/10, I'm going to put a half. A half would be about right here, halfway between 0 and -1. That would be 1/2. And that would be -1/2. And think of this denominator, it's 10. So that's the same thing as -5/10, isn't it? Because 5 is half of 10. So that's where halfway would be. So -7/10, that would be like 6/7. It would be right about here. It's going to be closer to the halfway point than to the -1. And that's how we graph fractions on a number line. Always use integers. All right, let's put it all together now, and we're going to try to evaluate. And that just means, that's a fancy word for solve or find the value. We'll get the word value in there. So evaluate, and we're going to write in simplest form. That means reduce it all the way. So if we had a question like that, we would plug in like negative 2y over x for x equals negative 2, y equals negative 4. We want to be able to plug in those values for x, and we're going to use parentheses when we plug those in. So for instance, negative 2, my y is negative 4. I'm plugging that back in for y. So parentheses negative 4 over x is negative 2. And then I want to simplify each part of that fraction first. So I'm going to simplify this top part, the bottom part, and then I'm going to divide them. So negative 2 times negative 4 is positive 8. Negative 2 is on the bottom. 8 divided by negative 2 gives us negative 4, or I could just divide by my common factor of 2, and I would get 4 over negative 1. And then 4 divided by negative 1 is negative 4. So simplify it all the way. I'll give you one more to try, and please pause the video after you record this question down and see if you get this one right. 5w minus 12 over 3x for w equals 2 and x equals negative 4. Go ahead and pause the video. And now for the solution. So I did 5 times 2. Remember, a number and a letter, that means multiply. So 5 times 2 minus 12 is on top. 3 times negative 4 is on bottom. And up here, I'm still going to do order of operations here. So I still multiply before I subtract. So I'm going to do the 5 times 2 next. And I get 10 minus 12. And then the 3 times negative 4 right here gives me negative 12. Now I'm still going to simplify that top part. 10 minus 12 gives us negative 2 over negative 12. I divide by my common factor of 2, and I get negative 1 over negative 6. And that's just like Johnny saying I have to pee in the middle of class. That's not proper. So a negative divided by a negative gives us a positive. So it's positive 1/6. And that's the proper way to write that. This lesson was brought to you by Johnny and Susie.